Good morning, everyone, and welcome to Litmus Test. Last time we talked about physical and chemical changes, and today we're going to look at we're going to look at atoms, molecules, elements, stuff like that. So, again, when we left off with Minecraft last time, we said Minecraft has some limitations in the way it can approach certain analogies, so keep that in mind as we go through today. But we are going to try and do the best we can with the idea of atoms and elements and molecules. We're going to start with this crafting table and my really creaky chair. I hope you hear that. I hope everyone hears the really creaky chair as I just kind of shift around, get good creaks. So, first let's start with the ideas of iron, gold, we've got copper, tin, osmium, charcoal. These are all, well, not charcoal, but these metals are all metals on the periodic table, and you can all find them. You can write down their symbols and atomic weights and masses and all sorts of interesting little numbers that someone will ask you on a test, and you'll be like, great, that's wonderful. When we talk about the idea of atoms, elements, and molecules, one of the things we want to say is that if we have some substance, like this block of iron, we can break it down progressively smaller by cutting it up. And when we get to a piece that we can no longer cut up, we say that's an atom. In this case, an iron nugget is kind of like an iron atom. It can't be cut any further without not being iron anymore. In real life, a nugget of this size would still contain many, many, many atoms in it, but in Minecraft, this is basically like an iron atom, since we can, make iron with it and stuff. We can do similar things with gold and with other metals for which nuggets have been coated, like tin, copper, and osmium. Even osmium has atoms. Obviously not everything has nuggets or atoms, so in the case of Minecraft, sometimes things like this function kind of like atoms, like a charcoal piece is already kind of like a charcoal atom, but that's where the analogy breaks down. We're going to move past that. From this idea of atoms and elements, we note that both this gold nugget and this iron nugget, they're both nuggets. And this tin nugget, all of these are nuggets, but they're not the same stuff. Just like these are ingots, but they're not the same stuff. It's gold, iron, and tin. And these things have certain properties. We can see these very clearly when we try to make tools with them, in Minecraft at least. So let's make some tools here. We can make, an iron pick, and we can make a gold pick, and we can't actually make a tin pick, but we can make an osmium pick, because that's been coated in. So there we go. We'll toss this over here. There's osmium. Osmium's a very dense, very interesting dense element. But there we go. So we have this idea that we can make things using these different elements, and the substances that we make are very similar. They're all pickaxes, but they all have different properties. You'll notice this iron is 4 hearts and 1.2 knives. This golden pickaxe is 2 hearts and 1.2 knives, and this osmium pickaxe has 6 hearts and apparently 500 HP. We also know from experience in Minecraft that iron will last longer than gold, but gold mines faster than iron. And we know that the gold doesn't last as long as iron because gold in real life is softer and more malleable and it bends. But this osmium actually lasts longer than the iron does. And you'll notice it just looks tougher and more durable because osmium in real life is a more dense element. And so we have one case where we actually did want to keep some things consistent with real life, kind of. Besides, oh look at this, we got a thing. We can do something else with this stuff. I've built a little alloy kiln here, and if I toss in some tin and some copper and put in a little bit of charcoal, I'm going to make something over here. Now, in Minecraft terms, this is very much like a chemical change, but in real life terms, this is still a physical change. We're making some bronze, which is a physical change because this is not a new, well, this is a new substance, but kind of not. Alloys are weird. So in one sense, this is a new substance. It has new properties, and we can't make it go back into copper and tin. But in another sense, the way metals work, is that you just have a lot of atoms that are floating about in there. So we could think of this as if this bronze ingot, we can imagine what's really happening, well, really, you know, quote, really, unquote, happening, is that somewhere in here we've got some copper nuggets, and somewhere in here we have some tin nuggets. And even though this is not a valid recipe, and even though the ratio of copper to tin is, as you can see, a little bit off there, being closer to this or this, that this makes bronze. There, we'll just kind of hold that right there. So we can see that it's the idea that they're just floating about and they make bronze. And this is an alloy. And these alloys, metal alloys, they just float about and make new stuff, which is very much like, very similar to the way atoms work in molecules. If we want to talk about atoms and molecules, let's look at making a pickaxe. So if I combine these, what are, for Minecraft's purposes, wood atoms, with some iron, quote, atoms, unquote, or not really, I get this iron pickaxe. And this is the way a molecule might work. You have some things that are bonded together to make a new thing. And when we talk about this, let's grab the signs here. So we know that if we want to make an iron pick, right, we're going to need 2 sticks plus 3 iron ingots. And we know that's an iron pick. And if we were being, really clever, we might write something like 2 sticks plus 3 iron makes pick. I don't have enough space there to write it all out, but you get the idea. 2 sticks plus 3 iron makes an iron pick. Okay. There we go. So we can write something like that out. Whether or not that's helpful or clear, whatever. But we could write it down. We can write it out like that and say, okay, that's how the recipe for making an iron pick. And this is how a molecule might work, and this is how we might write things out in a molecule. Although the use of this arrow is a little bit weird. Instead of that arrow, we might just write an equal sign. I've been too used to Python there. 2 sticks and 3 iron equals an iron pick. And that equal sign is a little different from the notion of a reaction. So let's write this again. Iron pick is 2 sticks plus 3 planks. We could write this as a chemical formula that if we imagine that the planks and sticks are atoms of elements, they're not, but we can imagine that they're kind of like that. Then we could say that an iron pick, which iron pick is the name of something. Iron pick is a substance, and iron pick is its name, the name of that substance. We can say that it has the chemical formula, perhaps, of 2 sticks and 3 planks, St2p3. That this is a chemical formula that the sticks and planks go in together. Similarly, we could say that a gold pick is made of 2 sticks and 3 gold. And we could say that an osmium pick is made of 2 sticks and 3 osmium. And this all checks out, right? That's exactly how we would make an osmium pickaxe. We'd have some sticks, and we'd toss that in here, and we'd toss some osmium on top. And the idea behind this shaped crafting of making osmium ingots and sticks is really important to molecules, because molecules have atoms that aren't just stuck together like this bronze. The difference between a molecule of osmium pickaxe and just an alloy of bronze ingot is that in a molecule, the atoms of the elements are stuck together in a particular arrangement. I can't just move this anywhere and get an osmium pickaxe. I can't mix them up in any arrangement to get an osmium pickaxe. Only this works to get an osmium pickaxe. But it doesn't really matter how the copper and tin are arranged in here. In fact, they can go in either way, and I still get charcoal happening, or I still get bronze happening, I shouldn't say charcoal. I still get bronze happening, because what's happening here is the atoms are just mixing on an atomic scale in an orderly fashion, but on our scale, just in a very large fashion. They just, they just melt together, mix, you get bronze coming out. And the difference there is that the atoms are in a different arrangement, and they're in a different form. We don't talk about molecules when we talk about alloys, but we do talk about molecules for other molecular substances. That sounds a little weird, but let's look at, before the sun goes down on us, let's look at one more area where we might talk about molecules versus not molecules. And for that, I want to pull up, I'd really like it if we had more ionic compounds listed, because I don't think, oh, we do have some salt, there we go. We have a salt block. Let's grab some salt here. I wasn't sure if we did. Oh, nope, it just wants to give us basalt. I don't want basalt. I just want salt. In fact, I want all of the salt and some salt blocks. Why? Who knows? So we can, this salt block doesn't really do anything for us. There are recipes that we can, use with it, but as, oh, look at that, we can make salt blocks out of salt. Who knew? So we know that salt is composed of two elements, sodium and chloride, which is kind of like saying that salt is composed of two different types of atoms. Now, obviously not iron and gold, but two different types of atoms combined to make salt. And the way they do this, again, this is not real. This is a limitation of Minecraft. But the way that they do this is similar to like a TNT block recipe. There's a structure that the atoms fit in to make this salt. And this is what we call an ionic compound, where we have a crystal that is built of different elements, generally between a metal and a non-metal. If those are two metals, as they are here, we would put them in a crystal and we would get something like electron in this case. Or if we wanted to make a real good crystal structure here, we might make this. And in this might be the crystal structure of bronze. Maybe. Who knows? Or something very similar to that crystal structure. It's not exactly there. But you'll notice the idea is that these are in repeating patterns, more or less. It's hard to demonstrate in a 9x9 or 3x3 grid. So when we have two metals mixed together, like copper and tin, we get an alloy called bronze, in which the atoms are arranged in a repeating, ordered crystal structure. When we mix a metal and a non-metal, again, we take some sticks, which is a non-metal, and we take some iron, which is a metal, we get a molecule. Well, in Minecraft we do. In real life, if we mix a metal and non-metal, we're going to get salt. In Minecraft, when we put some non-metals together like this, we get a molecule. And again, this is where Minecraft is limited, so let's go over the takeaways for today before we get too crazy. A molecule is when we have a bunch of atoms that are arranged in a particular order, and molecules generally are not stackable, or they don't connect to each other. Alright? An alloy is when we have a bunch of metal atoms that are just mixed together in some way, and they're just two metals that mix together. We don't talk about molecules when we talk about alloys. An ionic compound, like this salt, is when we get some metal atoms and some non-metal atoms arranged in a repeating, nice, regular crystal structure. That might be our salt structure, except there's more sticks. Again, we would talk about crystals with an ionic compound. We wouldn't talk about molecules, because there's just a repeating crystal structure of atoms. And atoms are just tiny bits of elements, which are just things that are different substances that are pure. Bronze is not an element because it is composed of two atoms, two elements, And an iron pickaxe is not an element, because it's composed of 2 different elements. But atoms are the tiniest things you can get of a single element while still being that element. And elements are just 2 different types of stuff. And we can write all of that using all of this fancy chemical formulas, but we're going to cover chemical formulas a little bit next time. I want to keep this a little bit short. I don't want to blow everyone up. So, until next time, stay safe and don't catch on fire.